Hi, I'm Bruno Adorno, and welcome to this video in which I'm gonna show you how to calculate fractional vegetation cover in Google Earth Engine. Uh, in This project is hosted in the github.com/badorno/fractional vegetation cover. You can scroll down, know a little bit more about us, the workflow to calculate fractional vegetation cover, how to access the code editor if you're a first-time user in this link. You can get the code to the repository where you can have access to the script. And also, if you want to know more about concepts on fractional vegetation cover and remote sensing in urbanized areas, please refer to this lecture here. And if you want to know more details of how the script works, please refer to this fractional vegetation cover, Google Earth Engine Explained. But now this video is the hands-on in which we're gonna calculate fractional vegetation cover using Google Earth Engine tools and all the environment. Okay, so now scroll up and click it on the repository if you haven't already saved. Uh, the, the script is opened here in the left panel as FR refined in the reader section. You can save it if you make some addition here. This is helpful in case after you want to make some adjustments, if you want to advance the script for other issues. But if you only want to read the script, that's fine. So now we're going to hide the script for a moment because we're mostly using this mapping area down here. And I'm going to explain very briefly on the tools that you have in Google Earth Engine. You have zoom in and zoom out tool to get closer or farther from an area. You have this hand to drag your image. You have this tool that allows you to insert markers and probably extract data from your image at the pixel level. You have also the line tool, so you can draw a line in case you need. Uh, this allows you to draw a polygon in whatever shape you want, and this allows you to draw a rectangle. Usually very useful to draw a bounding box around the area of interest or selecting samples as well. On the right, you have the possibility to turn on the relief. So if I get closer here, you can see without the relief information and with relief in case you need for some reason. Or you can turn on the satellite image provided by Google Earth Engine with or without markers, without to have a cleaner view of the high spatial satellite image they provide for you. But this image, as in Google Earth, you're not able to extract much information like the pixel information you need. Other raw data is provided by Sentinel-2 or Landsat. In this case, we're using Sentinel-2. So we're going to start by selecting a study area. I'm going to pick Goiânia. Let me write it full. So Goiânia in Brazil, where I'm from. And then we're going to draw a rectangle to select your area of interest. For instance, let's pick this area over here. I can turn this off just to keep it. And now I'm going to run the code. As I run the code, this right panel appears asking me to select start and end dates. I suggest you to pick an interval within 1 year, but close to 1 year, so you can retrieve information from every season and probably derive a fractional cover index that has higher value for evergreen vegetation, lower value for those vegetated areas that are dry during the dry season. After selecting your date, you click on Calculate Fractional Vegetation Cover. What shows up for us is an image that is cloud-free and shadow-free as well. We also already have calculated the NDVI that uses the red and near infrared band. You can see very easily how NDVI highlights the vegetated area in a scale that goes from -1 to 1. Usually vegetated area has values above 0.35 that becomes higher as it becomes denser or more photosynthetically active, and close to zero values are related to bare soil, to urban infrastructure, as you see in white colors. And water body usually has negative values, as I can show you in this water body right here. So it's colored in blue. Um, okay, after you have loaded your NDVI and RGB imaging, it's time for you to choose a dense vegetation area. For instance, this forest over here. I inspect, I see high spatial resolution, and with NDVI, the overall is a dense vegetated area. You can see the NDVI, these pixels vary a little bit. You have some pixels brighter than others because there is some variation in density. But for fractional vegetation cover purpose, we want to make this basically all equal to 1 because all pixels are covered by vegetation, right? To do so, we select to draw a rectangle, create a new layer, and then we name it NVIS, which is the threshold for a dense vegetation area. We import as picture collection, just in case you want to export afterwards your file as a shapefile and use in another uh, geoprocessing environment. As you have rectangle selected and NVIS selected, draw a rectangle over here. Fine. Now let's create another rectangle named NVIO, which is going to be our non-vegetated area samples. I like to go to airport lane, so if you know where the airport is located in your city, please move to the airport. And within the airport lane, you can assure that you don't have vegetation, right? So please draw a rectangle, trying to get as much as possible in more whiter color as you see in the VI layer, avoiding the borders as much as possible. After you drew these two rectangles to collect the samples, in this area you run again and you click on calculate fractional vegetation cover once more. Then you again select satellite if you want. So after you select the first samples and run the code and calculate it again, the fractional vegetation cover, you can lower down a little bit the panel and you'll see which value were selected for NDVIS and NDVIO. Usually I think these are values based on my experience that approaches what NDVIS or NDVIO could be, but we could try to inspect if there is any other pixel that could be better representative of these thresholds. To do so, we have these two new layers that shows up in this layer panel. The FR non-veg is important for us to inspect from dark to white color, being white, those that was calculated with more than 1% of fractional vegetation cover, and black, the areas that has no vegetation. So if there's any gray or white pixel that you are sure that should not have vegetation, you could sample them. So if you go back to your airport lane here, you can try to find some pixels, for instance, in this airport lane here, that could be sampled as a non-vegetated area. So you select NDVIO in your geometry imports and select insert marker, and maybe pick this gray pixels, and you run again and calculate fractional vegetation cover. You can see now that our NDVIO increased to 0.18, and as a result, you have a more defined airport lane here. Still, the non-vegetated areas are mostly covered in black, and this area that has some important vegetation are in white, or that has minimal 1% vegetation. You for sure can visually inspect more of your image. If you didn't like your samples, you can select them. You unselect here, then you can select the sample and delete, run again, and this way you go refining by looking and visually inspecting your results. Now let's go to an area with dense vegetation and turn on the FR-Veg layer. For instance, let's check how this area is. This area is interesting. You can see this area that was more exploited for human use, and this area that is more preserved. And even in this area that is preserved, you can find some isolated pixels here. And as you can see only vegetation, I could assume these pixels are artifacts, maybe due to shadow issues in a forest ecosystem or some different species that has different signals to the satellite. By context, I could assume this is an area full covered by vegetation. This way, I choose to sample some areas here. I'll draw some rectangle this time. So some pixels that I trust that is 100% covered by vegetation. I run again and calculate fractional vegetation cover. So our NDVIS reduced to 0.75. Let's see how our FR-Veg is in this area. Okay, so you see by resampling, we refined our classification, making this whole area continue forest cover, and this other area that was exploited, we have some area with lower than 90% vegetation. So again, this was explained in the video before, but this FR-Veg ranges from 90% to 100%, from white to dark green. Therefore, everything in white has less than 90% vegetation cover. The final result is showing the FR layer. Okay, so now we can have a better picture of from 0 to 1, which is the range of our fractional vegetation cover, or 0 to 100%, how the area is covered by vegetation or not. So important gaps appears in our map. And areas that is more preserved is 100% covered. You can identify some isolated trees or group of trees. In this case, some water bodies has value of 0, roads and some built-up elements has value of 0. We can compare this FR value with the NDVI. So if we load NDVI, you can clearly see distinct water body from built-up structures and vegetation. However, in built-up area, compact as this, we see some greenness, a very low NDVI values, but what we wanted was to make this value as close as possible to zero. And this was obtained by taking a threshold of NDVI O. So in this case, you can see that all this area goes to zero in white color against the NDVI, which has some greenness. And the area with some remaining vegetation is still preserved in the result. So other important tool in Google Earth Engine is the inspector, which allows us to uh, identify the values of different layers at the same pixel. So for instance, this area here of vegetation, if I click here and I drag this down, so it's going to show to me NDVI of 0.83 and FR of 1. So as this represents an area covered with vegetation, this is a result that makes more sense, thinking of how much a pixel is covered by vegetation compared to other land uses. Same way, the area of houses here, if we inspect this area, the NDVI is 0.24, but our fractional vegetation cover is 1%. So very, very close to zero. Other comparison could be done in this more open build-up landscape. So the NDVI appears a lot greener than our fractional vegetation, which increases the contrast between vegetated and non-vegetated area. So we get a closer look. So where the trees really are, we tend to have higher values than NDVI, and the build-up areas bring us lower values than NDVI. So for instance, probably this tree over here. Let me turn this on. This pixel over here bring me 0.74 NDVI and almost 100% for FR, or fractional vegetation cover. On the other hand, this pixel here related to build upland, which had an NDVI of 0.26, give me a fractional vegetation cover of 0.019 or 2%. Okay, in our list we also have the FR1. If you saw the last video, we showed that this code also calculates the fractional vegetation cover, taking different thresholds for NDVI-S of 0.85 of NDVI, and for NDVI 0, a value of 0. This could be thresholds of maximum and minimum NDVI in a scene that only has vegetation and no water body, for instance. If we pick this threshold for NDVI-S and NDVI-O, I believe the result is still better than NDVI to display the fractional cover with between 0 and 1. However, we still see in a dense forest area that there is some variation of fractional vegetation cover, where actually we could assume to have uh, only vegetation, and this problem was resolved in now the FR that we calculated, which provide us more refined result by the resampling process. And also in compact neighborhoods, we tend to have a higher level of grayness because the threshold for NDVI-O was set to 0. In our case, we set NDVI-O at 0.18, which means there is like from 0 to 0.18 is all considered zero fractional vegetation cover in our result. But if we just take the minimum NDVI in the scene, you may risk to tell that a pixel is partially covered by vegetation while it's not. For instance, if we inspect this area over here, there are some houses here, as we see. So NDVI is 0.15, FR equals 0, and FR1 equals 3%. It's very low, but still our refined results try to solve these small issues as well. And after you finish refining your results, you may want to take a look in your study area how the FR result is. But once you're happy with your result, you can export your image and also your NDVI samples. But now make sure if in the script you're exporting your FR result. To do so, in line 146, replace what is written here by FR, which is the FR layer. You run again, calculate, and now you can safely export your FR result. You can write a task name or FR download. The scale is 10 meter for Sentinel-2. Also, you can choose the folder in your Google Drive where you're saving your project or your image, and choose the name for the file, FR test, and the file format, GeoTIFF, so you can open in other GIS software. And then you run. After the download is complete, you can go to your Google Drive to the folder you selected and you can download your image. The same for the NDVI-S and NDVI-O, which you can save as shapefile or as CSV format. But you can select here as HP, choose the name, test, choose the drive folder, and click and run. So you do this for if you want to export the samples you took. Okay, I hope you have liked. If you have any issue concerning the code, any questions, please refer to our GitHub. And you can write to us here, click in new issue. After you have created your GitHub account, logged in, you can add a title of the issue and type your description over here. And that was it for now, and enjoy.